you, Mr. Chairman, and thank you very much to our witnesses. I really appreciate your patience today. I want to start with Dr. Friedman. Dr. Friedman, many of us have had questions about the scientific capability that we'd gain in terms of an asteroid retrieval mission and how that then contributes to going to Mars. And so I wonder if you could very quickly give us a sense of what the science is that's so different than what we would get from a lunar landing and mission if that were the interim step that was chosen.
Yes, thank you for the question. First of all, it's important to understand that, of course, the mission, the asteroid retrieval mission, wasn't selected for, or its rationale is not for, science. If it was, then we have a robotic sample returns, and we do missions to asteroids for science purposes. This is part of the human spaceflight program, and its primary rationale is a step for humans to take in space. Having said that, of course, the aspect of what humans could do on an asteroid to delve into the surface, to bring back, to conduct experiments related to future resource utilization, to perhaps drill a little bit, to do experiments related to asteroid science would contribute greatly not only to the knowledge about asteroids themselves and their relationship to solar system studies, but also to what the structure and composition and strength of an asteroid is and the diversity of them, so that we can someday we might have to deflect one for purposes of planetary protection. So there will be a lot of human-related science experiments on such an asteroid retrieval mission, but it's important to understand that the real reason for doing it is the human capability of being able to go beyond the moon, to be able to go on longer flight time missions, to be able to take larger systems with them for longer life support as a first step beyond the moon, and then to more subsequent larger steps after that.
So thank you. So I'm trying to appreciate then the critical technologies that are necessary with whatever the interim step it is that we choose, whether it's an asteroid retrieval or it's a lunar landing and lunar mission. And so I wonder if each of you very quickly could kind of outline what those critical technologies are, so that when we're trying to figure out how do we make the investment in next step to Mars, that we're investing in all the right critical technologies, whatever the chosen interim destination. And so if we could just kind of go down the line, that would be great.
Well, I think the fundamental one is related to life sciences and life support for human spaceflight once you're outside of the Earth's radiation environment and into deep space. Both the length of the system in microgravity and the radiation exposure are key questions. I think that's the dominant one for long-duration human spaceflight. The other big technology that unfortunately is going to have to wait for more robotic missions to Mars is the entry, descent, and landing on Mars. That's huge. That's an unsolved problem. It's not going to be, you can't learn it on the moon, you can't learn it on an asteroid, you can only learn that on Mars itself. And I think what we're doing in the robotic missions for exploration of Mars is the other key technology. So our electric propulsion technology is a long-duration flight, but that we do know how to do.
So could I hear from the other witnesses whether or not it's a lunar mission or an asteroid retrieval?
Well, one of the key things that you want to develop to go to Mars, in fact to do any kind of planetary exploration, is the ability to solve some of your logistical problems. And that means learning how to use the materials and energy that space have to offer, rather than bringing everything we need with us from the Earth. And I contend that the moon is an ideal place to do this, because it's close enough that we can begin to start doing this robotically with teleoperated machines that could basically pave the way for human arrival later. Now, survival on a planetary all planetary surfaces are hostile. There's no second Eden. There's no second Earth. They're all require us to protect the crew from radiation from the environment and to create our own life support consumables. That can be done on the moon, and that can be done, in fact, a lot of the key technologies we would use there, we would use on a trip to Mars eventually anyway. The other main technological area is learning how to effectively explore planetary surfaces, and that includes using both humans and machines synergistically so that each one builds on the value, on the benefits of the other. That's another experiment that can be done on the Moon because it's a little planet of great complexity. So that's the way I look at it.
Thanks. And could we hear very quickly from Dr. Squyres and Mr. Cooke?
Yeah, just very briefly, I agree with Dr. Friedman that the two most challenging technologies required to send humans successfully to Mars and bring them back are, first of all, deep space life support and habitation, and second, entry, descent, and landing to the Martian surface and ascent. I'll point out that, to me, the connection between particularly the asteroid retrieval mission, which involves proximity operations with a rock that would fit comfortably in this hearing room, I see no obvious connection between that and any of the technologies or capabilities that are required for Martian exploration.
I would agree with most of everything that's been said. I would add that the Moon is unique in that it is a planetary surface that has partial gravity like Mars. It has a dust environment that you have to learn to deal with. You can develop surface operational techniques in a partial G environment in spacesuits, learning those techniques and how to explore and how to get the most out of the missions. So in 2006 we had a conference that laid out objectives for the Moon, and there are many of things that you could do there that would contribute to long-term human exploration.
Thank you for allowing us to go on a bit, because I think this is really the core of what it is that we've got to come to some agreement about over these next several weeks. I think it's been a shame that NASA as an agency and the industry has not had the kind of concerted direction, both from the Congress and from various administrations, that really is appropriate to the task that's in front of the agency. I shared Dr. Squyres' concerns about, aligning the budget and the workforce to the work that we're charged with doing. I think it's been quite unfortunate that the agency's been put in a position of having a lot of ideas thrust into its basket and none of the money that's required to perform in the kind of way that we need it to. And so, Dr. Squyres, I know that you talked about the importance of human exploration and how that can serve the task of galvanizing the collective spirit of all of us that then will allow for the match of the money with that spirit and excitement. And so I appreciate that. So I want to explore what's going on with SLS and Orion. Because, Dr. Squyres, you indicated in your statement that no human-rated launch system in NASA's history will fly as infrequently as that projected for SLS and Orion. And the effect of such a low launch rate, as you stated, would make it difficult to maintain program momentum and to keep flight teams sharp and mission ready. And Mr. Cooke, you indicated in your statement that SLS and Orion are essential to any human spaceflight strategy. So I wonder if you can comment about how funding to date, which has been lower than what's been authorized, has impacted your position on this, and if SLS and Orion are critical regardless of the interim strategy, aren't we putting NASA behind the 8 ball by not adequately funding SLS and Orion?
I'm deeply worried about this, as I noted in my written testimony. If you look at the current plans for SLS and Orion, they call for an Orion flight, no crew on board, in 2014, launched not on SLS but on a Delta IV Heavy to go far from the Earth, come back and re-enter and validate that part of the system. Next, we hope in 2017 would be another flight, again with no crew on board. And then finally, the first flight with an actual crew on board would be 8 years from now, in 2021 at the earliest, to probably orbit the Moon, which is, I think, as I said, a logical next step. And then a flight rate after that that's maybe something like every 2 years or so, as we can afford to do it. If you look back at every human-rated flight system that we've ever had over NASA's history, none has flown so infrequently, and I'm deeply concerned about this. You can quibble all you want about whether SLS is the right design, whether Orion is the right design, but those decisions have been made. What I now see is a program that is not funded at an adequate level to allow that system to be proven out at a logical pace. And that's why I beg of you as a committee not to pile more objectives on NASA beyond what they're already trying to do, because they don't have enough money to do what they're trying to do now.
So if we came to a conclusion that Mars is the next ultimate destination, and we need a launch vehicle, wouldn't it make sense, given that we know that's what we need, to make those investments that we have to make to keep us on a pathway, but to do it in a way that ensures that, forget the 8-year path, that there are some number of events, of activities that ensure safety and, mission teams that were able to provide the kind of support that they need and to be mission ready. It would seem to me that we would need to really, if that's our goal, that we'd really need to front load what we're doing so that we could stay on a pathway that would result in any kind of success over the next decade.
I think there are two elements. I think the first element is, as you say, to more adequately fund SLS and Orion so that they can be developed and proven out on a pace that really supports, I think, a safe pathway towards developing these cislunar orbit capabilities that we've talked about as the next step. And the other is that in parallel with that, begin to sensibly and aggressively pursue international partnerships that may provide other pieces of the puzzle. I stress, however, that if we intend to involve international partners in a deep, meaningful way in this adventure to Mars, we need to recognize that those international partners should have a seat at the table when it comes to negotiating what the steps beyond lunar orbit ought to be.
Mr. Cooke?
I think you're definitely on the right path. Once again, the capability, for instance, for SLS with its capacity, it's not only just lifting mass, but it's also volume of payloads and diameters that you need for the kind of human spaceflight elements that we're going to launch down the road. And the deep space crew vehicle has capabilities that are incredibly important as well. The flight rate is dependent and is driven totally by funding at this point. They're going through the development, which is a cost, but then the recurring units that you get to when you actually start flying missions, of course, they're expensive. So the flight rate in itself is driven by funding. And I'll go back to a point I made earlier. The fact that they definitely need more funding. I also believe that starting with inflation, because the effect of a flatline budget with no inflation increase means that your buying power is decreasing and it's compounding interest. So as you work down the years, your buying power is actually going down. You're able to afford less and you're flying less. And so the inflation aspect of the funding is a first step in that discussion.
Thank you, Mr. Chairman.